proving for a strictly decreasing function. Let fx be a function on an open interval whose derivative is negative. Now we are considering for the negative part. Now let x1 is x less than x2 in the open interval I. Therefore, for the closed interval x1 comma x2 becomes a subset of a I. Now fx is a continuous function on the closed interval on x1 comma x2 and differentiable on open interval x1 comma x2. So by Lagrange's mean value theorem, mean value theorem, there exists at least one value C where C belongs to x1 comma x2 in the open interval such that fx2 minus fx1 upon x2 minus x1 is equal to f derivative C. So this was Lagrange's mean value theorem. Now we are having derivative part as a negative, so we can write it is less than 0. Okay, because we have given that f derivative C is less than 0. Now to this part, what we can write it? Fx2 minus fx1 is less than 0, as we are having x1 is less than x2, and from this it becomes x2 minus x1 is greater than 0 on I, on the intervals. Okay, so fx1 is greater than fx2. Okay, we are having now fx1, from this part we are having fx1 is greater than fx2. Now x1 is less than x2, sorry, in I is the intervals, and this implies that fx1 is greater than fx2. Therefore fx is strictly decreasing function in I. So when x1 is less than x2 and fx1 is greater than fx2, then it is strictly decreasing function.